Right, in problems 5 through 10, we're going to be using reference triangles to solve for the given trig functions based on the given information. So in problem 5, we're told that tangent is equal to 1/5 and cosecant is greater than 0. So things we know from that information is that tangent is positive and cosecant is positive, which means we must be in quadrant 1. So if we draw ourselves a reference triangle, I should put that reference triangle in quadrant 1, where all the x and y values are positive. I'll put a coordinate axis on there, and then label the sides. So tangent I know is opposite over adjacent, so I'm going to make my opposite side 1 while my adjacent side is 5. Leaving me with an unknown hypotenuse, so I'll go to the Pythagorean Theorem, which says that 5 squared plus 1 squared should be equal to h squared for hypotenuse. Giving me 26 is h squared. So that hypotenuse must be equal to the square root of 26. Even when we're considering the coordinate plane, the hypotenuse will always be positive, so I don't need to worry about a plus or minus here. Using that information, I want to solve for the cotangent of pi over 2 minus theta and the cosecant of pi over 2 minus theta. So cotangent of pi over 2 minus theta, I can use one of my identities to change that to tangent of theta. Now I can solve that based on the triangle. If I go to my opposite over my adjacent side, I get 1 over 5. Also, tangent theta was the given information. So we didn't even need the reference triangle for this piece. Cosecant of pi over 2 minus theta. Well, from the cofunction identities, we know that this is equal to secant of theta, which is hypotenuse over adjacent. So square root of 26 divided by 5. In problem 6, we are just given that theta is in between 3 pi over 2 and 2 pi. This means we are in quadrant 4. I don't even need any in-depth analysis to get there. So since we're in quadrant 4, I drew my reference triangle in quadrant 4. And in that quadrant, x values are positive, while y values are negative. So that's 63 over 65, which became the adjacent side and the hypotenuse respectively, both should be positive. Now, in solving for my missing side y, I end up getting that y squared is equal to 256. In order to solve for y, I need to take the square root of both sides, and taking a square root here involves getting the square root of a variable. And anytime I get the square root of a variable, I should end up with a plus or minus. And from there, I can reason a way to get rid of one of those options if I need to, or I could keep both solutions. In this case, since we're making a reference triangle, I want to have just one value for that opposite side. And now, because I'm in the fourth quadrant, my y values should be negative. So out of the plus or minus 16 that I have options to take here, I'm going to take the negative value, because again, I'm in the fourth quadrant. From here, everything else in the problem was straightforward. I needed to get secant of theta, cosecant of pi over 2 minus theta, and cotangent of pi over 2 minus theta, which I can ultimately solve using just the sides of a triangle. In problem 7, I'm told that alpha is between pi and 3 pi over 2, which puts this in quadrant 3. So I drew my reference triangle in quadrant 3. I had the sine of alpha was -4 over 5, so my opposite side will be -4, while my hypotenuse is 5. Because again, my hypotenuse will always be a positive number. So anytime I have a negative in the given information, I'm going to need to put that negative on one of the legs. But I'll use the Pythagorean theorem to come up with my missing side x, giving me the equation x squared equals 9. So x is plus or minus 3. Now because I'm in the third quadrant where x values are negative, I'm going to take x being equal to negative 3. In problem 8, I know that cosine is positive while cosecant is negative. Keeping in mind that cosecant has the same sign as sine, this must be in the fourth quadrant. Since that's the only quadrant where cosine is positive and something else is negative. So cosine is 40 over 41, so my adjacent side is 40 and my hypotenuse is 41. Use the Pythagorean theorem to get my missing side y, and I find that it's either plus or minus 9. Because we're in the fourth quadrant where I have negative y values, I again take the negative value for 9. Notice over here when I'm looking for the tangent squared of b, I end up with a positive solution in the end, positive 81 over 1600, even though tangent of b comes out to a negative number. So remember that taking the square of a negative will come out to a positive, so it's okay that tangent squared comes out positive. In fact, tangent squared should always come out positive, even though tangent itself is negative in this problem. Number 9, we're given that cotangent is positive while secant is negative. This having the same effect as tangent being positive and cosine being negative, we must be in quadrant 3. So I was told that cotangent is equal to 4, but I like having fractions when I set up these reference triangles. So I'm going to change 4 to be 4 over 1, so I can have my adjacent side be 4 and my opposite side be 1. But I am in the third quadrant where both x and y are negative, which means I should label these legs as negative 4 and negative 1, even though there was no negative in the given part of the problem. This is because if I'm given both x and y together, if there is a double negative, it will divide itself away. So in the case of the third quadrant, where we're looking at a tangent or cotangent value, those double negatives get hidden in the given information. So just be careful when you have an angle or a reference triangle in the third quadrant, because you might need to add 2 negatives to your reference triangle. But we can then go through and use the Pythagorean theorem to find h. I got that 17 is equal to h squared, but I just wrote down that h is equal to the square root of 17. I did not bother with plus or minus here because the hypotenuse is always a positive number. I'm never going to put a negative value on a hypotenuse. Then problem 10, I'm told that cosecant is negative while secant is positive. This again having the same effect as sine being negative while cosine is positive. That must mean I am in the fourth quadrant. So cosecant is equal to negative 101 over 99. So I make my hypotenuse 101 while my opposite side is negative 99. Again, recall that the hypotenuse is never going to be negative, so I'm going to put that negative on the 99, which is the opposite side, and then I'll solve for my missing side, x. I end up getting that x squared is equal to 400, so x itself is plus or minus 20, but I'm in the fourth quadrant where the x values are positive, so I choose the positive value out of this square root.